In this video, we're going to use the factor theorem to determine whether a binomial is a factor of a polynomial. So when we work on factoring a polynomial, we're actually trying to figure out the expressions that can be multiplied together to form the original trinomial. So for example, the factors of 2x squared plus 7x plus 3 are x plus 3 and 2x plus 1. That's basically saying that if I take x plus 3 and multiply by 2x plus 1, we can actually get the original polynomial back. So the factor theorem tells us that given a polynomial and a possible binomial factor are x minus r. Okay, so in this case, we don't know that x minus r is a factor. We can determine whether it's a factor using the factor theorem. The factor theorem tells us that x minus r is a factor of f of x if f of r equals 0. So for example, we can say that x plus 3 is a factor of f of x equals 2x squared plus 7x plus 3, because if we plug in f of negative 3, we'll get 0. So it actually makes a lot of sense if you think about it. So remember how we discussed finding roots of a polynomial. So for example, if we had x squared plus 4x minus 5 equals 0. Well, remember we factored it and we had x minus 1 times x plus 5. And then we said x minus 1 equal to 0 and x plus 5 equals to 0. And we said that that means that x equals 1 and x equals negative 5. Well, the factor theorem just does this in reverse. So if we wanted to check if x minus 1 is a factor, well, x minus 1 corresponds to x equals 1, right? So that's why we'd plug in f of 1 and make sure that equals 0. Similarly, if we're trying to check if x plus 5 is a factor, well, x plus 5 corresponds to the root x equals negative 5. Right? So we just check that f of negative 5 equals 0. So the remainder theorem can actually be used to use the factor theorem to help us determine whether a binomial is a factor. So remember we said instead of using direct substitution, we can actually use synthetic substitution. So for example, if we were trying to check if x plus 3 is a factor, well, we know x plus 3 corresponds to the root x equals negative 3. So we'd put negative 3 up here in the upper left-hand corner, and we check if f of negative 3 is equal to 0, right? That's what we're trying to do right here. We're trying to say, is f of negative 3 equal to 0? And then we can use synthetic substitution by taking out all these coefficients and then following those steps. And if we get a 0 as a remainder, that's basically saying that f of negative 3 equals 0. So that's how we can say that x plus 3 is a factor. So here's our steps, okay? So here's how we're going to use the factor theorem to check our factors. We'll make sure that our polynomial is in standard form and add in 0 for any skipped terms. Then we set up our table for synthetic division and write down the coefficients of the polynomial. We'll write the value of r in the upper left-hand corner. Remember, if we have x minus r, that's going to be r, and we have to use negative r if we have a binomial in the form x plus r. Then we bring down the first coefficient, multiply by r, and add to the next coefficient. We'll keep repeating until we have no coefficients left. If the final value in the last row is 0, right, if our remainder is 0, that means that the binomial is a factor. So here's a problem-solving tip. So you can use direct substitution or synthetic substitution with the factor theorem, but I personally prefer to use synthetic substitution because it's easier and I feel like it prevents mistakes. Especially when you have a lot of larger numbers and exponents and you're trying to type everything in the calculator. I think that synthetic substitution kind of like avoids some of those issues. But you can use direct substitution if you really would rather do it that way. So let's try to determine whether x minus 2 is a factor of this polynomial f of x. So to start off, I'm going to make sure that it is in standard form and that I don't have any skipped terms. So I don't see any skipped terms, so I'm going to go ahead and add in my coefficients of 1. So remember, if I'm working with a binomial x minus 2, that means that r equals 2. So I'm going to put this r in the upper left-hand corner and then write out these coefficients. So when I write out my coefficients, here's what I get. And so I'm going to start off by bringing down 1. And then I do 2 times 1, so that's 2. Negative 2 plus 2 is 0. And then 2 times 0 is 0. I do negative 12 plus 0, so that's negative 12. Negative 12 times 2 is going to be negative 24. 8 plus negative 24 is going to be negative 16. 2 times negative 16 is negative 32. Do 32 plus negative 32, and that gives us 0. So we can say that x minus 2 is a factor of f of x. Now you can go ahead and pause the video and try doing this example on your own. So So x minus 5 is going to correspond to r equals 5. So we put 5 in the upper left-hand corner, and then we write out the coefficients of f of x. So we have 1, -7, 7, and 15. We bring down 1. 1 times 5 is 5. -7 plus 5 is -2. -2 times 5 is -10. 7 plus -10 is -3. -3 times 5 is -15, and 15 plus -15 is 0, so this is a factor. So let's try to determine whether x plus 3 is a factor of f of x equals x cubed minus 13x minus 12. So x plus 3 means that r is going to equal -3. Let's rewrite f of x because I noticed that I have some skipped terms that I need to add in. So I have 1x cubed, and then I need to add in my 0x squared. And then I have minus 13x and minus 12. So now let's do our synthetic substitution. So we have -3, and then we have 1, 0, -13, and -12. So I'm going to go ahead and bring down 1. 1 times -3 is -3. 0 plus -3 is -3. -3 times -3 is 9. -13 plus 9 is -4. -3 times -4 is positive 12, so -12 plus 12 is going to be 0. So yes, x plus 3 is a factor of x cubed minus 13x minus 12. So now you can go ahead and pause the video and try doing this example on your own. So you can see here that this polynomial is in standard form, but it doesn't have an x squared term, so we need to add in 0x squared. Since we're trying to figure out if x plus 2 is a factor, remember that that's going to mean that r equals -2. So I put my -2 up here, and then I write out my coefficients. So I bring down 1. 1 times -2 is -2. 2 plus -2 is 0. 0 times -2 is 0. 0 plus 0 is 0. 0 times -2 is 0 again. -8 plus 0 is -8. -8 times -2 is 16, and -16 plus 16 is 0. So x plus 2 is a factor. So given a binomial x minus r, you can determine whether it's a factor of the polynomial f of x using the factor theorem. If f of r equals 0, then x minus r is a factor of f of x. You can determine whether f of r equals 0 by using direct substitution or synthetic substitution.